In Algebra, Lesson 9, Arithmetic Sequences. Recursive formulas is what we are really working with our arithmetic sequences. Here are your standards listed. This is from your textbook, Lesson 4-7. And here are the different standards that we are looking at in this lesson. Again, please read them through. These are your I can statements, so that as we finish this lesson off, you need to be able to distinguish between explicit and recursive. You need to explain how we change the terms to the next one, writing our sequences, how we can convert a list of numbers into a function, and doing all of these different things in here. And again, throughout the lesson, I'm going to keep coming back to these. Make sure you read them through and that they kind of make sense to you. So what is an arithmetic sequence? Recall, we have recursive formulas. What is that? It gives a rule for finding the nth term in our sequence. So it could be the 5th term, it could be the 7th term, it could be any of our terms that we are looking at. For the nth term of a sequence from one or more previous terms. So if I'm given the arithmetic sequence and I'm given this recursive formula, it says a of 1 is -5, and then I'm going to take, remember this just means previous term plus 3. It says for n greater than 1, remember it could be also for n greater or equal to 2. Both of these would work. I would not mark either one of them wrong. So a recursive formula, what would this generate? First term is -5, and we are continuing to add 3. So if we would continue to add 3 each time, this would be our sequence that we generate. It says the sequence is arithmetic because there's a constant difference. And when we talk about a constant difference, this does not always need to be subtraction. The difference could be addition, or it could be subtraction. What it cannot be multiplication or division. So it could be constantly we're adding the same thing, 3, as we did up here, or it could be constantly that we're subtracting the same number. In a sequence that has a constant difference where we add or subtract, that's called an arithmetic sequence. If it's not arithmetic, then our other one is going to be geometric. All arithmetic sequences can be written with a recursive formula. And this is going to kind of take us back to the beginning of the unit where we did slope-intercept and point-slope forms. Our first term, what's the nth term? Remember, this just means previous. That's what the n-1 is, previous term plus the common difference. Again, for n greater than 1, some people will like to change it and do n greater or equal to 2. Remember, you only do one of these, but they kind of mean the same thing because we are working only with whole numbers in our sequence. So what you're asked to do in this practice problems at the top of the next page is identify the common difference. So what are we adding or subtracting? That's our common difference as we are looking at these. Then write the first 5 terms of the sequence. This is telling us our first term, the previous one, in this case, -40. So what is our common difference? D in that formula is a -40. We now want to list our terms. Well, our first one is given to us. It's 1,000. We are then subtracting 40 off. So I'm going to have 960. I'm going to have 920. I'm going to have 880. And I'm going to have 840. And I put the dots because if that sequence would continue, these are my first 5 terms. I would like you to try it for this one. Pause the video and see if you can identify the difference. And then we want to list the first 5 terms. If you were doing that, the difference is adding 3. If we are looking at our terms, you should have written down -24, -21, -18, -15, -12, ... telling us the sequence continues. As you look at the next notes, it says, okay, writing a recursive formula when we're given a sequence. It says, which of the formulas below is a recursive formula for the following arithmetic sequence? And it says, explain your reasoning. Okay, so we're going to look through each one, and I do want you to think of giving a reason for each. We have a first term, a to the n minus 1, then plus 10. So if we are looking at this, is our first term 5? So right off this one, no. Why? A to the 1 is supposed to equal negative 5, not 5. So we look at B. Okay, B, C, and D all have that first formula that we were looking for, that first term. So when we look at A, B, C, and D, they all have the first term. Okay, A to the n plus 1. We haven't seen that in any of our formulas. So because this is a plus 1, this one doesn't work. It is supposed to be A to the n minus 1 to give us the previous term, not A to the n plus 1. That'd be one term more. So if we are looking at this, it's always looking at the previous one plus 10. A to the negative 1, yes, that works. Minusing 10. This is the part where this one is off. So this one does not work. Why? We are adding 10, not subtracting 10. And then our last one here, if we look at it, we hope this one works. First term, a to the n minus 1 plus 10. Yes, it's right on. If we look at generating that, the first one is negative 5, the next one is 5, then we're going to continue with 15, and that is the sequence that we have listed up here. So be ready to kind of explain why they work or don't work when we look at your homework. Writing that recursive formula from an explicit formula. So we are now kind of going back to earlier this year when we looked at slope-intercept. So it says a recursive formula for a sequence is described here using x in terms of y. First, plug in the 1, 2, and 3 for x to generate the actual sequence. So if we are doing that, okay, if x equals 1, what is our sequence going to be? Well, we're going to have y equals negative 2 times 1 plus 3. The first number in our sequence should be, if we are looking at that, we're going to have negative 2 plus 3, which gives us 1. What's our next number in the sequence? X equals 2. Y is equal to a negative 2 times 2 plus 3. So we have negative 4 plus 3. Our next number is a negative 1. So if we were going to list our sequence, we have 1, we have negative 1, x3, y is equal to negative 2 times 3. That gives us a negative 6 plus 3. Negative 6 plus 3 gives us negative 3. So if we are going to generate the first 3 numbers, it looks now like each time we are subtracting 2. So look at that first slope that we had. We're going down by 2 each time. So could we continue? Negative 5, negative 7. It says now use the sequence to write our recursive formula. So as we now look at our recursive formula, we need the first term, a to the 1. So our first term in the sequence, a to the 1, is going to be positive 1. How do we generate the nth term? We take our previous a to the n minus 1, and each time we are subtracting 2 when n is greater or equal to 2. Again, remember, you could have n is greater than 1. So when we look at this, the question with this equation up here that I want you to think about is why is the first term, when we look at that, not 3? Why is our first term not 3 when we look at that equation? And the thing you want to think about is that this is the y-intercept, 0, 3. That's like the term before 1. So why is 3 not the first term? It's the 0 term, if we wanted to think of it that way. And our sequences, will always start with, when we are looking at it, the first term. So our sequences always start with the first term. So this is kind of like telling us that a to the 0 would be 3. And our sequences always start with the first term. So just be careful for that when you look at an equation in slope-intercept form or point-slope form. Again, go back and rewrite some of these if you need to and listen to the video again. This is hard stuff. We will probably have 2 videos for this lesson again. So writing a recursive formula given 2 terms. This is saying the 7th term in the sequence is negative 45 and the 11th is negative 65. Well, we want to write those as an ordered pair. So we're going to write it as 7, comma, negative 45. And our next term is going to be 11, comma, negative 69. So we have our 2 terms. The first thing it says is find the common difference or slope. Oh, we'll go back to the beginning of this unit. How do we find slope? y2 minus y1 over x2 minus x1. So in this case, we're going to take a negative 69 minus a negative 45. Remember, that's going to be the same as plus a positive. And in our denominator, we have 11 minus 7. When you are subtracting these two, as we are taking a look at that, we should have a negative 24 divided by, in this case, 4, which gives us a slope of negative 6. How do we find the first term? Well, we want to start with, I think, the easiest form of the equation to find the first term. You either want to start with slope-intercept or point-slope. To me, point-slope makes a lot more sense. So I'm going to start with y. So this was step 1. Step 2 is a long step. Step 2, you're going to put y minus y1 equals m times your x minus x1. So as we look at that equation, we want to substitute in. I'm going to pick the first point. So I'm going to go with y minus a negative 45, which will make it a plus 45, equals our slope. Our slope was negative 6 times x minus 7. Again, we're going to have to use the distributive property and get y by itself so that we can see it in slope-intercept form first. Negative 6x plus 42. In order to solve, we're going to subtract 45 from both sides. And again, if you need to pause the video as you're doing this, do so. Here's our equation in slope-intercept form. Negative 6x plus, in this case, or you could have a minus. In this case, we would have minus 45 minus this should come out with a negative 3. We want to think, what's our first term? If x is equal to 1, what is our first term? So we go back into our equation and we go y equals negative 6 times 1 plus a negative 3. And our y in this case is negative 9. So all of this work to get the first term. We now know when we're going to write our recursive formula. Remember, recursive formula starts with the first term. Our first term, if we are going to write the sequence, is negative 9. If it helps you to write and think of your second term, go to your equation again. Negative 6 times 2 would give us negative 12 plus a negative 3. Negative 12 plus negative 3 would give us a negative 15. What are we actually doing each time? Think of what your common difference is. And in this case, our common difference is to subtract 6. That was our slope in this equation. So when we write our answer, our a to the 1 is going to be negative 9. Could we generate more of these? We sure could by continuing to subtract 6. A to the n is going to be equal to a to the n minus 1. And what are we doing each time? We are adding, or in this case, we're actually not adding, we are subtracting 6 for n greater or equal to 2. Hope that made some sense. We'll continue with the rest of the notes as you come back.